4, problem 37 reads, the fastest pitch of baseball was measured at 46 meters per second. A typical baseball has a mass of 145 grams or 0.145 kilograms. If the pitcher exerted his force, assumed to be horizontal and constant, over a distance of 1 meter, A, what force did he produce on the ball during this record-setting pitch? And then B, draw free body diagrams of the ball during the pitch and just after it left the pitcher's hand. So this is momentum kinematics and Newton's second law, force equals mass times acceleration. So the mass of the ball is 0.145 kilograms. The momentum of the ball initially was at 0 because it was at rest, and when he completed his throw, would have been the mass times its final velocity, which is 0.145 times 46, which is 6.67 kilogram meters per second. So that is our J, our change in momentum. So now we need to figure out the time interval, so that we can figure out the force. So using kinematics equations, we know the initial velocity is 0. The final velocity was 46 meters per second. We don't know the acceleration. Distance is 1, and we're looking for time. So we use this equation that doesn't involve A. So distance equals velocity plus final velocity plus initial velocity divided by 2, all times time. And then we just insert our numbers. So 1 equals 46 over 2, solve over 2 times t. So solve for t, which our time interval is 0.043 seconds. So now we can bring this back into our impulse equals force times time equation. So the impulse, which we discovered earlier, divided by our time, which is 6. So we have 6.67 over 0.043 will give us our force, which is 115.1 newtons, depending on how you round. Now, for the free body diagrams before the throw, or kind of as he is throwing, is you have the force of gravity acting on the ball. So the ball will be accelerating downwards the entire time, but it's over such a short time interval that the acceleration due to gravity is negligible. And the force of the throw is going to be horizontal and constant. Just after the throw, after it leaves the pitcher's hand, only gravity is acting on the ball, so it's going to just follow a normal projectile motion.